The AI Standup for June 4th, 2026. NVIDIA is making a major push to move AI from the cloud into the physical world, unveiling new skills for robots and autonomous vehicles. At the same time, new research from MIT is challenging the bigger is better mantra, proving that smaller, specialized AI models can actually outperform the giants. And in the financial arena, the capital fire hose is still on full blast, with Anthropic securing a massive investment in a $65 billion funding round. Let's break down what this means for engineers, developers, and the market. First up, NVIDIA's aggressive move into embodied AI. At the recent CVPR conference, the company rolled out what it calls new physical AI agent skills. This isn't just a single model or a new piece of hardware. It's a comprehensive set of workflows designed to accelerate the development of autonomous systems that operate in the real world. Think robotics and self-driving cars. The initiative focuses on three critical stages of development. First, scene reconstruction, which is about creating high-fidelity 3D representations of the world from sensor data. Second, the generation of edge cases for testing. This is crucial. Instead of waiting for rare and dangerous events to happen in the real world, developers can synthetically generate them to train and validate their systems robustly. And third, policy training, which is the process of teaching the AI agent how to make decisions and act in its environment. By providing an integrated pipeline for these stages, NVIDIA aims to solve a major bottleneck in robotics. To put this in context, this isn't just a research paper. NVIDIA is simultaneously deepening its strategic partnerships in South Korea, a global hub for semiconductors and robotics. CEO Jensen Huang's planned visit to Seoul underscores the company's focus on securing the supply chain and market access needed to bring this physical AI vision to scale. For engineers, this means a more unified, powerful toolchain is coming online, potentially standardizing how we build and test robots. While NVIDIA is focused on scaling physical intelligence, a new study from MIT suggests that for digital intelligence, the future might be smaller and more specialized. Researchers used the classic game Battleship as a novel testbed for AI agents. The goal wasn't just to win the game, but to teach the AI how to ask better, more informative questions to locate the opponent's ships efficiently. The results were striking. A smaller, specialized model, trained specifically on the logic of inquiry and information gathering within the game's constraints, consistently outperformed much larger, general-purpose models like those from the GPT family. And it did so at a tiny fraction of the computational cost. This challenges the prevailing paradigm that simply scaling up model size and training data is the only path to superior performance. The MIT study highlights the power of what's known as inductive bias, building prior knowledge and constraints into the model's architecture. Instead of a massive, jack-of-all-trades model trying to infer the rules of Battleship from scratch, the smaller model was architected with a better strategy for learning. For engineers building AI applications, this is a critical insight. It suggests that a fleet of smaller, expert models could be more efficient, cheaper to run, and ultimately more effective than a single monolithic one for a wide range of business problems. This is a strategic shift from brute force scale to architectural elegance. Now, this debate between specialized versus general models isn't slowing down the flow of capital into the major AI labs. In one of the most significant funding stories of the year, Anthropic, the developer of the Claude family of models, has secured a massive new investment as part of a $65 billion funding round. The Qatar Investment Authority was a key participant, expanding its stake in the company. A $65 billion valuation places Anthropic firmly in the top tier of AI companies, alongside OpenAI and Google DeepMind. This kind of capital is essential for competing at the frontier. It funds the immense computational resources needed for training next-generation models, attracts top-tier research talent, and provides the runway to pursue long-term research agendas. For the market, this confirms that investors see a massive, durable enterprise being built on top of foundational models. It also highlights the immense capital moat in this industry, making it incredibly difficult for new, unfunded players to challenge the incumbents directly. Okay, let's fire through some of the other key developments this week in our Quick Hits segment. First, for developers on Apple hardware, Google has launched its AI Edge Gallery for macOS. This gives Mac users the ability to run and test Google's edge-optimized models, like Gemini Nano, locally on their machines, a big step for on-device AI development. Second, on the safety front, a coalition of prominent AI labs, including OpenAI and Anthropic, have co-signed a letter urging lawmakers to implement stricter tracking of synthetic DNA orders. The goal is to create a choke point to prevent AI from being used to design novel bioweapons. Third, a new category of tooling is emerging for the agent economy. A company called AGNT8 has launched what it claims is the world's first platform for recruiting and managing AI agents, treating them like a digital workforce. This points to the new infrastructure being built around autonomous systems. And finally, for performance engineers, a new guide from Towards Data Science details a technique called hardware-aware sequence packing. It's a C++ implementation designed to drastically improve GPU efficiency during LLM inference by eliminating the overhead caused by padding tokens. a must-read for anyone optimizing production models. So let's wrap this up with the key takeaways. For engineers and developers, first, MIT's research is a strong signal that you should consider using smaller, specialized models for specific tasks. They can deliver better performance with significantly lower computational cost. Second, for those of you optimizing inference, look into techniques like hardware-aware sequence packing to maximize GPU throughput. And third, if you're building complex agents, start evaluating observability platforms like LangSmith or Langfuse. They are becoming essential for debugging in production. For investors and market strategists, first, the massive $65 billion funding round for Anthropic reaffirms intense investor confidence in foundational model developers. The capital requirements in this space are enormous, creating a significant barrier to entry. And second, NVIDIA's dual focus on physical AI workflows and strengthening its South Korean supply chain partnerships shows a clear, integrated strategy to dominate not just the chips, but the entire ecosystem for robotics and autonomous vehicles. That's our analysis for this week. The trends we're watching closely are the maturation of AI agent infrastructure and the escalating tension between rapid innovation and the need for robust safety and governance. If you're a professional working in AI, these are the signals that will shape the next year of development. Make sure you're subscribed so you don't miss our deep dives. Thanks for watching, and we'll see you in the next one.